algebraic proofs today. We're going to be writing proofs in chapter 4. It's our proof chapter. We'll get to those when we get to chapter 4. We're just kind of introducing what the proofs look like. Maybe you've heard about proofs from older students who have been through this class before. In order to write proofs, we need to know that they're in 2 columns. We have our work on the left side and all the reasons why we're doing those steps on the right-hand side. So just a recap, we're going to be looking at addition, subtraction, multiplication, division, possibly substitution, and also the distributive property. So those are all listed there. We're not going to go through the details of them because it is review. These are new though, so let's talk about these. The reflexive property is when something is congruent to itself. You're going to see this quite a bit in chapter 4 when we're looking at congruent triangles, but it's really when anything is congruent to itself, so it could be angles as well. So angle A could be congruent to angle A. That's also the reflexive property. Symmetric property looks a little bit like commutative property, where you're just switching the order of things. Okay, so AB congruent to CD is the same thing as CD congruent to AB. The transitive property, let's take a look at this one. AB congruent to CD, and CD is congruent to EF, therefore AB is congruent to EF. What does that remind you of that we just learned? The law of syllogism, okay? That was that domino effect. An easy way to remember transitive is it kind of sounds like train, and these are all linked together like a train, saying that the beginning is congruent to the end, if they're all congruent to each other. Okay, so let's look at these options down here at the bottom and list what property they are talking about. What would I write next to angle W congruent to angle W? Reflexive, yes. We're going to see that one a lot in chapter 4. Let's look at the next one. If 2x minus 8 equals 10, then 2x equals 18. How did they get from the hypothesis to the conclusion on that? How did they get from the hypothesis to the conclusion? Not transitive, good guess. What did they do to both sides? They added 8 to both sides, right? Okay, so the reason is simply addition. Next one, if 4x equals 16, then x equals 4. What happened?
Division.
They divided on both sides, so division. And the last one.
Transitive.
Yes, this one is transitive. Okay, so we're going to be looking at some algebra and writing some algebraic proofs to kind of get our brains ready for a couple more proofs in the upcoming chapters. Questions on these before we try those? All right, so I said proofs are double column. So we're going to make 2 columns. This is what the book is going to give you as an example. So you're going to make a vertical line so you have your 2 columns. Now, this is possibly going to stretch some of your brains a little bit, and some of you are going to be happy that I'm about to say this. But in this section, this is the only time that I'm going to force you to not show your work. Okay? So if you're used to showing your work, for instance, what would we do on both sides in this problem right here? We would add 10 on both sides. So you write plus 10 plus 10. Do not write that. Okay? The way that you're going to show your work is different in this section. So what this is the given equation. So you're going to write given right there. Instead of writing plus 10, you're going to write addition over here. That's you showing your work, telling me that's what you're doing to both sides is addition. What would this be after we added 10 to both sides? Okay, so you're not going to show the plus 10 plus 10. I want you to do that part in your head. Okay, it's a good brain exercise for you. Okay, some of you do this anyway and you don't show your work, and it's a struggle for you to show your work. Okay, But in this section, I don't want you to because you're showing your work on the right-hand side by writing addition. Okay, what's the next step?
Division.
Yes, we're going to divide on both sides. What would we get for the left-hand side? X equals -6, and you're done with your proof. Okay, so the work is on the left without showing the work steps because you're putting the word on the right-hand side as showing your work. Okay, this is the only section the whole year that I'm going to ask you to do this. Unless you want to switch to double column proofs to show your work, you certainly can do that if you don't want to show the +10 and divided by 5. You can do all of your problems like this. It takes a little more space, but what about this one? What do I write over here on the right?
Given.
There are a couple of routes we could take on this one. What would you like to do first? Yep.
Plus 3x.
Add 3x to both sides. Okay, so we'll write addition. And now let's do the work in our heads. What would this change to?
7x plus 9, 16.
Okay, so we added 3x to both sides. What would be next? Subtraction. We're subtracting 9 from both sides. So now we have 7x equals
No.
7.
7.
okay, last step.
Division.
Divide both sides by 7. We get 1. Okay, let's try one where we are just getting a variable by itself. 5x plus 3y equals 25. We're solving for y, so we need to write given. What would be the first step in getting y alone? We need to do some subtraction. So what are we subtracting? Okay, so we now have 3y all by itself. And what would I write over here? Yep. What's the last step? Okay, now when we divide absolutely everything by 3, these don't simplify, so you're just going to leave them as fractions, but if you can simplify them, please do when you're on the homework. Questions? We're going to do the first homework problem together. You can just put it in your notes, and then you can skip this problem. When you get to the homework, we've got 3. Oops, I need a little bit more room here. All right. What do we do first? Yes. You do not, oops, this is given. Sorry, hold on. You want to write distribute. You don't want to write what? Multiply. Because multiplication means you're multiplying by the same thing on both sides, and we're not doing that. Okay, we're actually distributing, so you need to use the appropriate reason. So when we distribute, what do we write?
6x plus 33.
Okay. Now what are we doing?
Minus subtraction.
When we subtract, we end up with?
Give me a second.
Negative. Thank you. Okay, last step.
Division.
Okay, another possible reason you might use, just so you're aware, because you will use it on the homework and maybe even on the test, you can use combine like terms if that's what you're doing on that step. So keep that in mind. Questions? Okay, so this might be a stretch for some of your neurons in your brains if you're really in the habit of showing your work, but I want you to try to do this in a double column manner so that we're getting ready for the other proofs coming up. Questions?